I have another 5 videos from the practice test. In this example, we want to multiply and simplify completely. We have 5x minus 1 squared. A lot of people are tempted to apply the squared to the individual terms, but we can't do that because of this subtraction. What we need to do instead is rewrite this as 5x minus 1 times 5x minus 1, and then we can use our multiplication rules for multiplying. Some people like to use the FOIL method. 5x times 5x would be 25x squared. 5x times negative 1 is negative 5x. Negative 1 times 5x is negative 5x. Negative 1 times negative 1 is positive 1. We want to simplify by combining any like terms. We'll have 5x squared. Combine these like terms in the middle. Negative 5x plus negative 5x is negative 10x. So 5x minus 1 squared simplifies to be 25x squared minus 10x plus 1. On this example, we want to multiply in scientific notation. Scientific notation is where you have a number in between 1 and 10 multiplied by a power of 10. We have 9.11 times 10 to the 4th times 4.8 times 10 to the 8th. And when we do this multiplication, we want to take into consideration significant digits or significant figures. The number of significant digits in the answer should be equal to the least number of significant digits in the numbers being multiplied. So we'll think about that after we do our multiplication. But when we multiply in scientific notation, we can multiply the numbers together, 9.11 times 4.8, and then multiply the powers of 10 together. When we multiply the powers of 10 together, it allows us to use our rules of exponents. So in my calculator, I'm doing 9.11 times 4.8, and that gives 43.728 times 10, and we're going to add the exponents. Since we're multiplying since we're multiplying expressions with the same base, we add those exponents together. So 4 plus 8 is 12. When we did that math, we got 43.728 times 10 to the 12th. And we want to express that number in scientific notation. So if you'll recall, I mentioned that in scientific notation, our number needs to be in between 1 and 10. The number that we have here is not in between 1 and 10. So we're going to move that decimal place 1 place to the left, making that number smaller. To compensate that for that 1 place that we moved the decimal, I need to add 1 to the exponent. So that gives us 4.3728 times 10 to the 13th power. So we can eliminate these 2 to the 14th power. But remember I said that we need to pay attention to significant digits. So in our first number here, we have some significant digits. 9, 1, and 1 are all significant digits, so we have 3 significant digits. And here we have 4 and 8 being significant digits. And so we have 2 significant digits. That means that we want to have 2 significant digits in our answer. The least number, that's 2. So we're going to round this to 2 decimal places to make this 4.4 times 10 to the 13th. So this will be our solution. We also want to write this decimal notation of our answer. So that's expanding the scientific notation to the decimal format. We have 4.4 times 10 to the 13th. We're going to move that decimal point 13 places to the right. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that was 4, 4 with 12 zeros. Maybe I didn't do enough zeros. Let me check. We did. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We should do 13. So let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's 12 zeros. So I'm going to group these zeros in threes, and we can see that we have this as our answer, and that might be 44 billion. On this question, we want to find the quotient and remainder using long division for x squared plus 11x plus 32 over x plus 3. I'm going to take x plus 3 and divide it into x squared plus 11x plus 32. When we do long division, we focus on the first term of what we're dividing by and the first term of what we're dividing into. You can think of this as division. How many times does x divide into x squared? That's x. Or you can think of it as multiplication. What can I multiply by x to get x squared, which is x? Once we get that, we write the x down. And we're going to multiply that x by both of these terms and write those terms down here. Let's do that multiplication. X times x is x squared. X times 3 is 3x. And the next step in the process is to subtract. So I'll change these signs. Both of them are positive. We change it to negative to subtract. X squared minus x squared is 0. 11x minus 3 is 8x. And we'll carry down the next term. We'll repeat that process over again. Focus on the first term here and the first term here. You can use division. Divide 8x into 8x and you get 8. Or think of it as multiplication. What can I multiply by x to get 8x? And that's 8. We're going to write that 8 down up here. And we're going to multiply the 8 times both of these terms. Write that multiplication down here. So 8 times x is 8x. 8 times 3 is 24. We're going to subtract, changing those signs. 8x minus 8x is 0. 32 minus 24 is 8. So our quotient is x plus 8, and our remainder is 8. On this example, we want to solve the equation 8y squared minus 2y minus 1 equals 0. We're going to solve it by factoring. Now, to solve it by factoring, there are a few different ways you can go about doing it. I like to use a guess and check or trial and error method, but a lot of students who are just learning how to factor like to use an AC method or grouping method. So using the trial and error method, the numbers that go in the front of my binomials need to multiply to be 8y squared. So I know I'm going to have a y and a y. I need to think about the factors of 8. Factors of 8 are 1 times 8 and 2 times 4. I'm not sure which one is the right answer, but I can make a guess and I can check it. That's why it's called guess and check or trial and error. You try something and you check to see until you find the correct one. So we're going to try the 8 and the 1 for now. And then the numbers that go in the second half of the binomial need to multiply to be 1. So let's write a 1 and 1. Now what I need to check is to make sure that I get the correct middle term. I've already made sure that the first term is right and the second term is right, but I don't know if the middle term is right. So I check by multiplying the inside and the outside. That would give y and 8y. If I add those two together, I'm not going to get the right middle term of 2. So let's try something else. Now my only choice for this second part was 1 and 1. And even if I switch the order 1 and 1, it's still the same. So I'm going to make my changes on the front for this example. So let's change it to 2 and 4 instead of 8 and 1. If I have 2 and 4, and I check the inside, that's 4y, and the outside, that's 2y, can I combine those together to get the middle term of negative 2y? Yes, you can. You can do a negative 4 and a positive 2y. That means if I trace this back, I need a positive here and a negative here. So I factored completely 2y minus 1 times 4y plus 1 equals 0. I'm going to set each factor equal to 0. That's using the zero product property. The zero product property says if you have two numbers multiplied equal to 0, then one of your factors has to be 0, A or B. So it allows you to break down your equation. Once you've broken it down into these two equations, you're going to solve each one. So I'll add 1 to both sides. That gives 2y equals 1. I'll divide by 2 and we have y equals 1/2. Subtract 1, we have 4y equals negative 1. Divide by 4 and y equals negative 1/4. So we've solved the equation and our solutions are positive 1/2 and negative 1/4. On this example, we want to factor completely using the formula for sum and difference of cubes. Now the formulas for sum or difference of cubes are as follows. We have a cubed plus b cubed, and that factors to be a plus b times a squared minus ab plus b squared. You have the difference of cubes, it's very similar. That's a cubed minus b cubed will factor to be a minus b times a squared plus ab plus b squared. So those are the formulas that we're going to be using, and we want to factor r cubed plus 27. In order for us to use these formulas, we have to write it so that we can identify the a and the b in the formula. So here I can see that the a is r because I have r cubed, but the 27 is not in the right format. And I know that 27 is 3 cubed. So now I've identified that a is r and b is 3, and I can follow the pattern of the formula. That will be r plus 3, a plus b, a squared, that's r squared, minus ab minus 3r, and then plus b squared, that's plus 3 squared, which is 9. R plus 3 times r squared minus 3r plus 9 is the factor form of r cubed plus 27. Thank you for checking out my videos. Have a great day.